Hello everyone, my name is Shashank Singh and I am from IT3C and I am here to explain the topic polynomial representation, addition and subtraction. The polynomial representation is an implementation of linked list. So let's get started. What is polynomial? A polynomial is derived from the two words poly and nomial. The poly means many and the nomial means terms. As here we can see the general polynomial expression is written which is in a form of which is with a variable x in the form of this a into x to the power n plus b into s to the power n minus 1 and so on. We can clearly see that a, b and c and the rest are coefficient and the power terms in the form of n are called exponent. The n should always be a non-negative integer which is called a degree of polynomial. It is essential characteristic of a polynomial that it consists of two parts. That is, one is coefficient, where we can see that a, b, c are the coefficients, and the other is exponent. We have discussed earlier that n minus 1, they are the exponent form. So let's take an example. As here we have taken 10x square plus 26x. Here 10 and 26 are the coefficients and 2 and 1 are the exponential value. Here s to the power 2 and x to the power 1. They are the coefficient value. We should always keep in mind the following points for the polynomial. The sign of each coefficient and the exponent is stored within the coefficient and the exponent itself, and the addition terms having the equal exponent is possible one. The storage allocation of each term in the polynomial must be done in ascending and descending order of their exponent. These are the 3 points we should always keep in mind. So let's get further. The representation of polynomial. There are two ways to represent a polynomial in a memory. The polynomial can be by the use of array, the simple way to represent a polynomial with a degree n, and store the coefficient of n plus 1 terms of a polynomial in array. So every element will consist of two values, coefficient and the exponential form. So let's get started with an array. For an example, we have taken a polynomial, a simple polynomial 4x cubed plus 6x square plus 7x plus 9. The polynomial represented using arrays or linked list, it doesn't matter, but first we take with the first we will explain with the help of arrays. The array representation assumes that exponents of a given expressions are arranged from 0 to the highest value degree. They are represented by the subscript of an array beginning with 0. As we know that array we start from the array index starts from 0 to and so on. So the from it will start from the we will take the coefficient and the respected exponential form in the same way. The array representation we have let's for example the coefficient with a zero value of exponent zero value of the exponent form we have written it as 9 and so on. The next we have written with a 7 and 6 square with a coefficient index value at 2 we have written with the 6 and 6 and so on. These are the coefficient and these are the exponent forms. Now let's take a look for the linked list representation of a polynomial. The polynomial can be thought as an ordered list of non-zero terms. Each non-zero term is a two tuple which holds two pieces of information, the exponential form and the coefficient form. In a memory, the memory representation of a polynomial through the linked list. We will take three parts in a linked list with each node which will consist of three parts, that is data part and the exponent part and the address to the next node. This is the start pointer. uh, for an example we have taken here 4x cubed plus 6x square plus 10x plus 6. So we will get along with the first term. As we have you can see that the 4 which is the coefficient for this x cube we have written 4 here, the data value, and the exponential form which is the value of 3 we have written here, and this node is pointing to address to the next node. Similarly we have written 6x square. For the 6x square the data part we have written here, and it is represented in a memory in the same way as we have written here, and the coefficient we have written here and the exponential value and so on. For the 10x similarly the data part is here and the power part is here and it is a pointer to the next node, and similarly here the 6 the data part is 6 and the exponent form is 0 and it is pointing to the null. So this is the way we can represent a polynomial in a linked list. Now let's get started with the application of a polynomial. There are two forms we can do: the adding of a two polynomial and the subtraction. So now we will get started with the addition of a polynomial using linked list. For an example, we have taken an input for the two polynomials 5x square plus 4x1 uh, and plus 2x0, and second number is minus 5x1 minus 5x0. The output will be, as we will add, as we are adding 5x square, there is no value, there is no exponential form in a form of x square, so it will be written as it is. And we have x to the power 1 and minus 5x to the power 1, so they will be added and the result will be stored in a form of the result will be the negative, so it is written minus 1x square. And similarly for x to the power 0, 2x is 0 minus 5x 0, the result will be minus 3x square. Now let's take a second example: 5x square 5x cube plus 4x square plus 2x 0, and the second number will be 5x to the power 1 minus 5x to the power 0. Similarly, there is no term for the x cube, so it will be written as it is. And 4x square, there is no term in a form of x square in the second number, so it will be written as it is. And as we can see that there is no for x to the power 1, there is no term in first number, so it will be written as it is. And we can see that there is a term for x to the power 0, they will be added, it is, and the result will come in negative, as it is 2x square and minus 5x square, it will be minus 3x square. So we can see the memory representation using a linked list. For the first one, we are writing that the data part and the exponent form, and it is a pointer to pointing to the address of the next. And similarly for the other one, uh, yeah. Similarly for the list 2, and when they are added, they are represented in a memory like this: the node structure, the coefficient, the power, and the address of the next node. Now let's take a look on addition and subtraction of a polynomial. First of all, we will create a structure like this, and struct node start null, and pointing we will store the value to null. And for the start 1, start 2, start 3 and 4, and last 3 null. We will create a polynomial with the help of a structure like this, and create first of all, we will create a printf function. We will print like this, and in case we will create a switch option for user to enter a desired choice. And there are the several functions like creating a, first of all we will create a polynomial, display a polynomial, and display the polynomial, create the polynomial 2 and display the polynomial 2, addition of a polynomial 1 and 2, and display, and we will display in third one. And there will be a sub polynomial like this, and to display that sub polynomial. While and if the option is not equal to 9, we will return 0. First of all, as you can see, we are creating a structure like this to enter a number and its coefficient. If the start is not equal to null, the pointer will allocate the memory like this, and the coefficient will be equal to c. And the new node will pointing to the new node. The next part will pointing to the null, and the start will be pointing to the next node. Start will be equal to the new node. If this condition will run only if the start is not equal to, start will be equal to null. While the start is not equal to null, the PTR, the new node, will be equal to the start pointer, and the PTR, the next part of a PTR, will not be equal to null. While the next part of a PTR will not be equal to null, the PTR is equal to PTR, yani means next part of a PTR will be next part of a PTR will be equal to the PTR itself. And the new node will be equal to the n, and the coefficient will be equal to c, and the new node, next part of our new node, will be null. Similarly, you can see here for the negative term, for the subtraction of a value like this. Now let's take a look at a subtraction. If a PTR is not equal, if PTR pointing the coefficient of PTR to, we will first of all we will compare the coefficient part. If the coefficient of PTR1 and the coefficient of PTR2 are the same, then we will execute like this. the sum of ptr1 pointing to the num plus sum of ptr2 pointing to the num. The else part, if the following condition doesn't stand true, then we will execute the following part. Now we will get along with this one. If ptr1 is equal to null, the while ptr2 not equal to null, the start3 add node start3 ptr pointing to the num and ptr2 pointing to the coefficient, and ptr2 means ptr2 will hold the ptr value of next part. If ptr2 is not equal to null, we will point the start3 node to the num and the coefficient part itself. Similarly, we will execute the code rest of the code like this, and the final result of the final output will be like this. For example, we will get the following output in the window: enter the first polynomial, display the first polynomial. And the enter the first of all we will enter, for example we are entering like option 1, then option number will be 6, enter the number, we will enter the 6, enter the number 6, 5, and enter the number, its coefficient, it will be 2 and it will be 1, enter the number and option 2. We will get the polynomial at 6x2 square plus 5x1, enter the option 9. That's all. Thank you guys.